I'm trying to turn my 3D printer into a pen plotter without writing a single line of code. Unlike the new Bamboo Lab A2L, my A1 printer does not support their official cutting upgrade kit. So I had to find some kind of alternative. Today I'm testing a web app called 3D Plotter with a 3D printed pen holder. They claim you can convert any 3D printer into a precise professional pen plotter. Sounds very promising, but let's see if it's true. A pen plotter sees the world as a series of continuous lines. I'm going to use some of Marco's vector artwork with different levels of complexity for all the test prints. Let's start with a simple example, monoline lettering. As you can see, these lines are not expanded. The thickness of the stroke in your vector software doesn't actually matter because the final thickness depends entirely on the marker you choose. Because of that, I just removed the stroke entirely, since I noticed that if your lines have a stroke weight, the 3D Plotter app sometimes randomly expands some of them. Even though I set up my Illustrator artboard to match the printable area, subtracting the 28mm dead zone the pen can't reach, 3D Plotter completely ignores the original dimensions when importing the SVG. There are no precise transform tools, no way to see the actual measurements, and no alignment options whatsoever. Even the visual guides, which are supposed to help you position things by eye, aren't centered, so they actually end up throwing you off. To work around this, I tried importing the lettering inside a square that matched the build plate size, hoping I could align it perfectly and then just delete the square. However, the uniform scale only adjusts in 0.05 increments, making a perfect match impossible. Since the first artwork is very simple, we don't need to make a lot of adjustments. I settled on scaling it up 1.5 times and using the default outline mode. From there, the most important thing to adjust are the plotter settings, which depend on the marker you're using and how you have it positioned. To attach your pen to the printer toolhead, the 3D Plotter app recommends a printable pen holder. It is designed specifically for Posca markers, but their website mentions you can also use Sakura Pigma or Sharpie pens. It consists of three elements: the tube, the spring, and the cap. The tube keeps the marker from shifting on the X and Y axis, so your lines stay precise. It comes in 3 sizes, but I only printed 2. My Sharpie marker is a bit too thin, so I'm fixing that by wrapping it with some tape. Just make sure the fit isn't too tight, otherwise the marker might get stuck above the build plate and fail to reach the paper. The spring keeps the pressure consistent for steady stroke widths. You secure the marker with a screw, though it doesn't feel very secure. And it marks up the surface of the marker every time you tighten it. The third part is the cap that attaches everything to the tool head. Because the cap pieces are very fragile, I couldn't connect the tube the way it's shown on MakerWorld. To keep from breaking the mounts, I rotated the tube 180 degrees, which unfortunately made the whole setup less stable. I printed my pen holder with matte PLA, even though they recommend PLA+. Did you know that matte PLA is even weaker and more sensitive to humidity than basic PLA? I didn't know that. Anyway, I'll run into some problems with it later, but in my opinion, this pen holder was not properly designed for 3D printing in the first place. Let's get back to the marker position and the plotter settings. According to the guide, if you are using one of the recommended markers, you need to set Z-draw to 14 and Z-lift to 20 in the app. For me, it helps to think of Z-draw as the offset between your nozzle and your marker tip. However, you aren't actually measuring from the nozzle when you position the marker. You are measuring from the holder. I found that when the nozzle is touching the bed at Z equals 0, the bottom of the holder sits approximately 6 mm above the plate. To bridge that 14mm software gap plus the 6mm physical gap, your marker needs to stick out 20mm from the bottom of the holder. But at exactly 20mm, it would just barely touch the paper, making your lines look faint. To get a solid stroke, you need a little bit of pressure. So we need to let the marker stick out an extra 1 or 2 mm, making it 22 mm total. Knowing all that, you can adjust your Z-draw based on your specific marker and how you positioned it. Basically, just subtract 7 to 8 mm from the distance your marker sticks out from the holder to get your Z-draw value. Now we can export our G-code and transfer it to the printer using an SD card. The file already includes all the necessary instructions, so the printer won't try to heat up the nozzle or the bed, and it won't try to feed any filament. Before printing, I'm attaching the pen holder and positioning the paper. To keep the paper in place, I'm using tiny magnets, though you can also use tape. Also remember to use a build plate with a smooth texture for cleaner lines. Now we just choose the file and hit print. The first run was pretty stressful. When the marker finally hit the paper, I thought something went wrong, for a moment. Because it doesn't write like a human, it plots in a totally random sequence. Obviously, this has no impact on the final result. As you can see, the result is very good. If you look closer at this print, though, you'll see tiny imperfections. That happened because the pen had a little bit of play on the X and Y axis, meaning we need to add a bit more tape. I fixed that for the next print and got even better result. The third print was a test of how the size of the artwork affects precision. For the smallest design, we would probably need to switch to a thinner marker. If you're working with vector line work, you won't run into many problems. But let's test something with filled-in areas. To avoid the pen crossing over the same areas twice, I'm uniting everything using the Pathfinder tool. Then I imported it into 3D Plotter but forgot to switch to solid mode, so I just cut an outline and had to reprint it. For some reason, the next print failed. I think it happened because relying on a single screw to hold the pen is just a flawed design, so it easily slips. I didn't touch the marker at all, I just exported the file once more and hit print. In one spot the pen moved up and didn't come back down, so I had to push it down manually. But the print was already ruined. On the final result I noticed that the fill bleeds over the outline. I repositioned the marker a bit lower for the next print and the bottom clip snapped off, so the cap would no longer lock into place. Eventually the whole piece just cracked right down the middle. Again, I used matte PLA, so it might work better with a stronger filament. I didn't want to reprint the whole thing, so I just glued it together to finish my tests. But using a tiny screw directly in PLA is also not a durable setup. Predictably, the screw stripped the plastic threads, so it just spins and won't hold the marker in place. To avoid wasting plastic on a reprint, I switched to a different marker and used the smaller diameter tube I already had on hand. This print turned out almost perfect. So I tried the next artwork with more details and smaller elements. Of course, the marker proved to be too thick. The fill bled over the outline again and we lost the fine details. I decided to switch to a fine liner, but switching between markers of different diameters is not an easy task. Naturally, I didn't get the amount of tape quite right, and you can see the liner shifting on the X and Y axis. That caused a mismatch between the fill and the outline, but that wasn't the only issue. When using solid mode, you cannot adjust the distance between the lines. If you need a thinner line for small details, you will also get gaps between the lines of your fill. I repositioned my liner and added some more tape for the next print, but the problem persisted. If you take a closer look at the tube and the spring, it still allows movement on the X and Y axis because of how it connects to the cap. That hurts the overall precision and causes the fill and outline to misalign. As you can see, we also have a few elements that did not fill at all. This is another bug in the app. If filled areas are disconnected from each other, the software sometimes fails to fill all of them, and you can't fix it later with a bucket tool. The final test is multicolor printing. The way it works is that you place the part of the artwork you want to be red on one layer and the part that needs to be black on another layer. The app then exports them as two separate files so you can switch markers between prints. The workflow here is pretty clunky. Normally you'd just cut and paste an element in place onto another layer, but here it takes some extra effort. This brings us to a bigger point about what actually makes software professional. For me, it's all about the level of control you have over the details and a seamless, intuitive user experience. My advice to the developers here: learn from the industry standards and don't try to reinvent the wheel. I also wasn't able to fill my red letters because the app couldn't recognize the cutout piece. When I told Marco about that, he said I was supposed to make a compound shape in Adobe Illustrator, but that was after I finished my test, so at the moment I had no choice but to find a workaround. And then hope that I aligned the black marker well. Unfortunately, I did not. To answer the question on the thumbnail, can it draw? Yes, and for simple line work it does a pretty good job. But is it a precise professional pen plotter? To check the precision, I scanned my best prints and overlaid them with the vector artwork. Is it easy to use? Definitely not. And it's also not scalable. Imagine you want to print a batch of 10 or 20 multicolor cards. You would get highly inconsistent results, and switching between colors would be a real pain. In general, I think the concept of using a 3D printer as a pen plotter is great, especially now that Bambu Lab releases new printers compatible with the Cutting Upgrade Kit. It is clear that there is a real demand for these machines to be more than just plastic extruders. Since A1 doesn't have the hardware to support active electronics, I hope Bambu releases at least an official pen holder that solves my headaches. In the meantime, if you have found a rock-solid pen holder design or a better software workflow, please let me know in the comments. I would love to try it out. Thank you for watching and see you in the next one.